Okay, so 4-2 is graphing to find a solution. So when you graph to find a solution, you're finding either no solution if they're parallel lines, one solution if they intersect at all, and they will only intersect at one point, not 2 points, just 1 point. Or it will be infinitely many solutions because the two equations themselves are the same exact line. Okay, so that's what we did in class. So the first thing I'm going to do is I'm going to graph my top equation. So I go up to 7, 1, 2, 3, 4, 5, 6, 7 here, and I make a dot on my y-intercept. And then I do my slope, which is 1/2. That means I go up 1 and to the right by 2, and then I play connect the dots. And I'm going to try to do this as straight as I possibly can because I am trying to solve the system of equations. And the only way I could really solve it really well is if I try to graph the straight line as straight as I possibly can make it. Okay, so now I look at the bottom equation and I go up to 3 and I make a dot. And then I go up 3, 1, 2, 3, and I go to the right by 2. And what we did before is it lined up real nicely, but sometimes what you have to do is you have to make an educated guess on where your intersection points are, and then you have to do something to check it. So now, if we look here, looks like my intersection point is at, let's see, this is at 4 here. So it looks like it's at 4, 9. We do probably want to verify, and I don't think I did this because we were graphing it exactly in class. But you do want to verify and make sure that the solution works in both equations. So you do want to make sure that 9 is equal to 1/2 times 4 plus 7. Which that is true. And then you have to make sure that 9 is equal to 3/2 times 4 plus 3, which is also true. Okay. So we have a few graphing ones. I just want to double check and see where we're at. So we only go to number 8. So now let's do the third one. Again, we can graph I'll keep the colors consistent here. Up 2 to the right by 1. And so our graph kind of looks trying to make it as exact as I could possibly make it. Okay. And then I have my top one, which is at 7, 2, 3, 4, 5, 6, 7. And that's a point there. And then I go up 1, right 1. Oh man, I think these are going to intersect off the graph. So let me make my straight line. I'm going to extend out my blue line here. Just so that what we could do is we can graph and get a rough estimate of that intersection point right there, which looks like it's going to be 1, 2, 3, 6. So it looks like 6, and maybe this is 10 here. So 11, 12, 13, maybe 14. So it looks like 6, 14 maybe. So let's take a look. 14 is equal to 6 plus 7. No, that's not true. So maybe 13. So 13 is equal to 6 plus 7. That works. Is 13 equal to 2 times 6 plus 1? And yes, that's also true. So 6, 13 is my solution. So it has to, so if I call it a solution, it has to work in both equations, not just one of them. Okay? All right, so then now number 5. We're looking at that, and let's see. So we have -3, and then we go down 3 and to the right by 1. So I have, oh, I mixed up the colors. I apologize. Well, now that I messed up the line, let's just restart it. Okay, so -3, and I go down 3 and over 1. I was like, I made the line all not straight. Okay, so now I messed that one up too. If I hold down my my pencil, it extends out correctly. All right, so there's that. Okay, so that is my top equation, and then my bottom one is at a +2. I should label my axis, and I should label some points, because that's really important to do. And then I'm going to go up 2 and to the right by 1. Which I don't have to extend out very far to get my solution. That's the whole reason why we're graphing these, is to get the actual solution, which it looks like the solution is at -1, 0. So so 0 is equal to -3 times -1 minus 3. Yes, that's true. Is 0 equal to 2 times, -1 plus 2? Yes, it is. So that is your solution. All right, last one that I'm going to do. Okay, so -4. Oh, just kidding. -3. And then up 1 over 1. So then we have this. Ay, ay, ay. Okay. Here we go. Just kidding. I thought it was going to hold down. There we go. All right, and then we go to -4, which is here, and then we go up 1 over 1. But what you notice is that they have the same slope. So because, hold it down. Because they have the same slope, these are parallel. Because they have the same slope, so there is no solution. If I graph them and I ended up graphing the same exact line, then it's infinitely many solutions. Okay? And that is it for this lesson.